All right, let's look at energy problem types now. So the first one we have here is a work. Work is that transfer of energy. You know you have work if there is force and motion. So work is equal to the force parallel times the displacement. Remember, we need the parallel component of the force, and direction does matter. Work is a scalar though, but if it comes out positive, that means we're increasing the kinetic energy, we're trying to speed it up, and we're adding energy to it. If the work is negative, that means you're decreasing the kinetic energy, you're trying to slow it down, and you're removing energy. If the work is zero, if there is no work done, there's no change in kinetic energy. You're not giving it energy or pulling energy away. Now there's three types of energy we can talk about. There's energy from motion, therefore we have kinetic energy. There's energy from height, therefore we have gravitational potential energy. And there's energy stored in a spring that's stretched or compressed, and that is elastic potential energy, where K here is the spring constant. We also can use the work kinetic energy theorem. This is if you're going from one point to another point. In order to do that, you need to identify point 1 and point 2. Choose where height is equal to 0. Ideally, it's the lower of the 2 points. You write out your equation here. You cross out anything that's 0, and you start substituting and solving using your energy types. Now, in a certain situation, there's a conservation of mechanical energy. So this is taking the work kinetic energy theorem and it's saying now there's no work in and no work done by friction, so it's adding more conditions to it. If this is the case, you need to do a very similar process here. You need to identify point 1 and point 2, choose where the height is 0, write out your equation, cross out those zeros, substitute and solve. Again, here is the equation for that mechanical energy conservation. Now we have two types of power. We have average power. That's the power that occurs over a period of time, maybe you running upstairs. If that is the case, you find average power by taking the work divided by time. You can find work a couple ways. One way is by multiplying a force times a displacement, similar to this method. The other way is finding the work directly out of the work kinetic energy theorem. The second type of power is instantaneous power. That's the power right now, just at an instant, at one moment in time. To find that, you need to multiply the force parallel times the velocity. I would recommend drawing a free body diagram in those situations. And those are your problem types for energy.